In this video, we'll be continuing the worksheet. On the back side, we're looking at dividing fractions. Okay? So the algorithm for dividing fractions is to keep, change, flip. We'll be doing that down here. Keep, change, flip. Okay? The flip part has to do with taking the reciprocal, finding the reciprocal, they call it, of a number. So up here at the top, you're being asked to find the reciprocals of some numbers, which means flip them. So when you have a fraction like 3/4, the reciprocal it's frozen up a minute. Let's see. Here we go. It's working again. The reciprocal would be 4/3. Okay. If you have 12/5, the reciprocal of the number is 5/12. Now, whole numbers aren't written as fractions to start with, but 2 is the same as 2/1. So the reciprocal of 2 would be 1/2. Okay. All right, now I want to show you the meaning. There's two meanings for division. All right, one meaning for division is that you're trying to take a quantity and split it into equal pieces, right? So like on this one, you know, or before we do that one, let's say you had 20 cookies and you wanted to split those among 4 people, okay? So if you had 20 cookies, let me scroll this down, oops. If you had 20 cookies, I'll erase this in a minute, and you wanted to split it among 4 people, you could use division to do that. And when you do that, you get 5. The 5 is telling you how many cookies each person should receive. Okay? That's one meaning, right? What makes it a little hard, though, is we're going to start with a fractional amount here. So think of it like half a cookie, and we're trying to split it among 4 people. Right? So let's suppose our cookie is a rectangle because it's easier for me to draw. Okay? Half would be here. This is half of it, right? But if I'm to split that among 4 people, I'm going to have to cut that into 4 equal pieces. Well, what I could do is cut it, okay? And then cut it again, right? And there would be my 4 equal pieces. So each person would get this much, okay? When you write your answer, you need to report it as what part of the whole. So you had half of some whole cookie there. That's what was in green. I broke that into 4 equal pieces so I could share it among the 4 people. So each one could get just a little bite, and I want to answer what that turns out to be. So what I need to think is what part of the whole that amount is. So I'm going to extend these little cuts throughout the whole cookie so I can see there's 1, 2, 3, 4, 5, 6, 7, 8 of that size piece. So my answer to the question, to this question, would be 1/8. That's one meaning for division. It's taking some quantity and cutting it into equal parts. That works well when what you're dividing by is a whole number, okay? The other meaning for division is just repeated subtraction. Like if I took that example of 20 again and I was thinking about repeated subtraction model, then what 20 divided by 4 would mean would be how many times could you subtract 4 from 20? In other words, how many 4s would there be in 20? So it's like a repeated subtraction. Here's 20. Take away 4, I'm down to 16. Take away 4 more, I'm down to 12. Take away 4 more, I'm down to 8, and so on, okay? Until I'm done. And then I was able to take away 1, 2, 3, 4, 5 4s. That's the other meaning for division, repeated subtraction. So let me illustrate that here. So 3/4 divided by 1/2. So we're starting with 3/4 of some whole, okay? So here's the whole amount. I'm going to cut it into 4 equal pieces. Then 3/4 would be 3 of those shaded in. So here, what I'm asking for, what I'm going to try to answer is how many halves? How many halves are there? Okay, so here I have 3/4 of a whole. How many halves of that same whole are there in that quantity? Okay, so here's one whole. That's one whole half. Okay, so that's one. This right here would be one entire half. But then this would only be half of another half. So that's one whole half, and then half of another half. So you know what the answer is to this question? How many halves are there in 3/4 of a whole? The answer to this question would be 1.5. Okay. So I'll just get that erased over there. There we go. Okay, so 3/4 divided by 1/2 equals 1.5, and that really would have been the same as 3/2 written as a improper fraction. Okay. Now, I'm going to go down here and show you what we typically do. Of course, we don't draw to get answers to the question. What we're going to wind up doing is changing the problem into multiplication. We're going to keep the first fraction, change from division to multiplying, and then flip the second fraction. So 9/10 divided by 3/5, if I use that idea, I'm going to change to multiplying, and then take the reciprocal of the second fraction. Once I've done that, I'm back to multiplying. So here it would be okay if you wanted to multiply straight across first, and you could leave this, you wouldn't have to write this step, you could just do it. And then simplify, okay? So first thing I might notice is that 5 goes into both, and I'd be left with 9 on top and 6 on the bottom. And then I might notice that 3 would go into both. And I'd wind up finally with 3 on top and 2 on the bottom. So that's always okay to do. You can multiply straight across. It's just sometimes right here, the numbers would be big and you might not be able to tell what goes into them easily. So if you had kept it where these numbers were smaller, like thinking 9 times 5 and 10 times 3, then what you would do is this. Let me get rid of that. Okay. What you typically show, I'll do it in blue. This is the algorithm I really want you working on. Once you've done the keep, change, flip, notice there's a 5 on top, and 5 goes into 10 2 times. So 5 goes into 5 once, it goes into 10 twice. As long as you divide out the same thing, top and bottom, you're not changing the original problem. Also notice that 3 goes into 3 once, goes into 9 3 times. Then that means all you have left on top is a 3 times 1. All that's left on the bottom is 2 times 1. And you typically don't even write that. You just do it. You just say 3 times 1 is 3, 2 times 1 is 2, and you're done. Okay? So keep, change, flip. That's important. Keep, change, flip. Okay? And then after you've got it written as multiplication, then you're going to use the algorithm like we did on the previous page, where you either multiply first and then simplify, or simplify first, then multiply. Okay. All right, so let's try 4/5 divided by 2. Okay, so first thing, before I even do keep, change, flip, I'm going to rewrite that so 2 is written as a fraction. Okay, then I'm going to keep, change to multiplication, and take the reciprocal of 2 over 1. So I'm going to flip it. Okay, then if you want to multiply straight across, you can. You'll get a 4 on top, a 10 on the bottom. Those are small enough. It's easy to do that way. you can simplify and get 2/5. Or you notice that 2 would go into 4 twice, and so then you'd see the 2/5 that way. Okay? And then if you're dividing mixed numbers, just change them to improper fractions first. So 2 times 4 plus 1 would mean 9/4 is being divided by 3 times 3 plus 1, which is 10/3. So then keep, change to multiplication, and take the reciprocal of the second fraction. If there's something that can be canceled out, you do it, but notice that 9 is just 3 times 3. And down here, we just have 2 times 2 and 2 times 5. So there's going to be nothing we can do to simplify that. So we're ready to multiply straight across, get 27/40, and I don't even have to look for something that would be common, because I already can tell from there that there's going to be no common factor on the top and bottom. So that's my answer, 27/40. And that's not a mixed number, right? Can't be written as a mixed number. So you're done right there. That's a proper fraction is your answer.